You hear about Nazi wonder weapons, secret jets, rocket bombs, super tanks. Almost nobody talks about the rifle attachment that bent bullets around corners. Not science fiction. Actual German engineering from 1943. The Krummlauf, a curved barrel extension that clamped onto the Sturmgewehr 44 assault rifle. Soldiers could fire from cover without exposing themselves. Tank crews could shoot at infantry crawling up their sides. A periscope sight let you aim without looking, but the barrel wore out in 300 rounds. Bullets shattered into fragments. The whole concept violated physics. Why did Germany waste resources on this? What did American tests reveal? What happened when you actually tried to curve a bullet? Eastern cities become kill zones. Soviet infantry assault German armor at close range. Tank crews discover a problem. The Sturmgeschütz assault guns. Excellent against enemy tanks. Terrible against soldiers 5 meters away with satchel charges. The main gun cannot depress low enough. The machine guns have blind spots. Russian anti-tank teams exploit this. They crawl underneath, plant explosives, disappear. 12 Sturmgeschütz lost in Kharkov in 1 week. Street fighting in Stalingrad proves the same weakness. You cannot defend a tank from someone you cannot see. Served as a lieutenant in an observation balloon platoon in the Great War. Called back to active duty as a captain in the 1st Panzer Division on August 1st, 1939. 1 month later, his division rolls into Poland, but his talent lies in weapons development, reassigned as a major to the munitions ministry in 1942. He studies the problem of defensive fire from armored vehicles. The solution seems impossible. Make the bullet go around a corner. Bend an 8mm barrel for the full-size 7.92 by 57mm cartridge. This works better, but the powder charge is too powerful. Pressure inside the curve reaches catastrophic levels. Barrel life, 100 rounds. Then failure, the steel warps, cracks, becomes unusable. Decision made. Switch to the shorter 7.92 by 33mm Kurz cartridge. The intermediate round fired by the MP-43, later known as the Sturmgewehr 44. By October 1943, the 93rd Infantry Division on the Eastern Front receives the first MP-43s. Production uses stamped steel parts. Cheaper, faster, revolutionary. Hitler initially opposes it. He wants bolt-action rifles and submachine guns. Nothing in between. But reports from the Eastern Front change his mind. October 2nd, 1943, Hitler orders 30,000 units per month. By the time production ends in 1945, German factories produce between 425,000 and 530,000 Sturmgewehr 44s. Total numbers disputed, records incomplete, but thousands reach combat units. Months earlier, Hitler dismissed machine guns as standard infantry equipment. Believed rifles served better. Albert Speer notes this in his memoirs. Perhaps the Führer finally grasps the savagery of Russian combat. The curved barrel receives backing. Rheinmetall-Borsig gets the contract. Development accelerates. Bored and rifled using standard armory methods, then cold bent to 90 degrees. No sights, initially. Special clamping apparatus bolts it to the MP-43 muzzle. Heavy, unwieldy. July 6th, 1944. Scheide and Professor Weniger from Rheinmetall-Borsig demonstrate the device to weapons division officers. The recoil is brutal, accuracy questionable, but the concept works. Bullets actually curve. If you value documented weapons engineering history like this, subscribe. It is the best way to support our work. Also, comment from which city you are hearing this from. This script is researched and factual, using sources from the United States Office of the Chief Ordnance Officer Report, dated July 18, 1945, authored by Captain P. B. Sharp, who conducted actual test firing, plus interrogations of Colonel Hans Scheide and German Major Fred Hartmann, who supervised small arms research at Kummersdorf and Hillersleben Proving Grounds. Now back to the information. Bend angle 30 degrees. Later variants include 45 and 60 degree versions. Only the 30 degree model enters real production. The attachment clamps onto the STG-44, using the same mount as the grenade launcher cup. Early production attempts to align rifling between weapon barrel and curved extension. Later versions abandon this. Engineers discover a bored-out section between muzzle and curve works better. Lets the bullet recenter itself. Slow the bullet as it enters the bend. 2 rows of 5 holes on later models. The shield redirects hot gases away from the sight. Without this, the mirror fogs immediately. Cover all angles around the tank. Designed for the Elephant tank destroyer, also called Ferdinand. 91 of these vehicles built. Formidable 88mm gun. No hull machine gun. Critical weakness. Infantry can approach unseen. The Krummlauf gives them a defense option. Rheinmetall-Borsig delivers 500 Versatz P units. Zeiss manufactures approximately 1,500 specialized sights by end of January 1945. That groove around the bullet that holds the jacket to the core. Weakest point. The bullet fragments, sometimes splits clean in half, sometimes shatters into multiple pieces. Exit velocity drops significantly. What leaves the barrel is not a bullet, It is shrapnel. Unintended shotgun effect. Useless beyond close range. But close range is exactly where tank defense happens. 5 to 15 meters. For that mission, fragmentation might work. Barrel life is the killer. German engineers claim 6,000 rounds. Reality proves different. The 30-degree version lasts 300 rounds. 45-degree version, 160 rounds. 90-degree tank version, fewer than 200 rounds. Testing shows why. The curve creates a stress point. Steel erodes. Pockets form. The throat and curved section enlarge. Rifling wears away. Accuracy deteriorates rapidly. Bullets tumble. Some stick in the barrel. Catastrophic failure risk increases with every shot. After 300 rounds, the barrel is finished. Replacement required. In combat, this is unacceptable. A soldier gets through one firefight, maybe two. Then the attachment becomes scrap metal. But technical intelligence teams recognize real engineering. The weapons go to testing. Captain P.B. Sharp conducts live fire at Headquarters Communications Zone. Colonel H.A. Quinn writes the assessment report. Office of the Chief Ordnance Officer, dated July 18, 1945. The Americans interrogate Colonel Hans Scheide, inventor, assistant to Dr. Speer at Rheinmetall-Borsig, also Major Fred Hartmann, former German Ministry of Armament, Division of Infantry Units, Berlin. He supervised small arms research at Kummersdorf Proving Ground and the large facility at Hillersleben. Good enough for man-sized targets at close range. Fully automatic fire creates problems. Sideways recoil. The curve tries to spin the shooter. Dangerous, uncontrollable. All bullets show serious distortion, fragments, deformation, cantilever breaks. Captain Sharp fires multiple magazines, examines every bullet that exits. None intact. Major Hartmann's interrogation verifies this. German testing produced identical results. The 90-degree version, impractical. Americans test it anyway. August 1945, Aberdeen Proving Ground, Maryland, both 30-degree and 90-degree versions. Also tests on the FG-42 rifle. Curved barrel there too. The 90-degree barrel cannot maintain accuracy beyond 50 meters. Maximum effective range with tank mount, 30 meters for sustained fire, 600 meters claimed maximum range for single shots. Laughable. The sight only matters if crew can see target. Periscope provides 12-degree field. Limited, but better than nothing. Total weight of Versat's P assembly, 23.5 kilograms. Includes barrel, mount, periscope, shoulder rest. Cumbersome. Requires vehicle mounting. Infantry cannot carry it. Moscow region. Task set in September. Testing begins December. Late model STG-44. No muzzle nut. Soviets test 90-degree version, a different from American sample. Gas relief holes in non-rifled section near the muzzle. 4 holes drilled vertically 90 degrees apart. Gas redirected horizontally through channels in the sleeve. Protective shield 17-degree angle. 1,000 rounds allocated for testing. They use fewer than 100. Failure stops trials. During initial firing, the sleeve deforms. Bullet force on the bent section warps the mounting. Barrel no longer aligns perfectly with rifle. Bullets deform worse. Only 8 impacts on target at 50 meters. Target is 1 meter by 1 meter. Terrible accuracy. Soviet report concludes the device is interesting. Recommends development of bent barrels for M9130 rifle, PPSH 41 submachine gun, and Sudev Automat Model 1944. Nothing comes of this. Too impractical. Documented in the Ordnance Technical Intelligence Report, plus Soviet trial documents from the Red Army Scientific Research, Proving Ground at Shirovo, dated December 1945. Now back to the information. Plans called for equipping every STG-44 armed infantryman with a 30-degree Krummlauf. December 1944. Presentation documents show distribution plans. 56 out of 179 infantry divisions have 2 assault platoons equipped with Sturmgewehr 44s. 10 divisions have 1 assault platoon. Rest have none. Issuing is 1/3 complete. Ammunition production limits further distribution. Expected additional monthly issue 15,000 to 20,000 Sturmgewehr rifles. Total goal 150,000 deployed weapons. By mid-1945, planners expect 70% of divisions equipped. By fall 1945, all divisions. But the war ends first. Most Krummlaufs never reach the front, those that do see limited combat use. No reliable after-action reports survive detailing Krummlauf use in battle. Anecdotal accounts exist. German veterans mention seeing them. Few claim actually using one. The problems are obvious. 300-round lifespan means constant replacement. Logistics cannot support this. Fragmented bullets reduce lethality. Infantry prefer normal barrels. Greater range, better accuracy, reliable. Tank crews have the same calculation. The Krummlauf weighs 23.5 kilograms for the full mount. Remote-controlled machine guns weigh less, work better. Several Jagdpanzer 38 and Jagdpanzer 4 tank destroyers receive remote MG systems instead. Panzer 470 also. These prove more effective. All benefit from this capability, but the execution fails. Materials. Science of 1943 cannot handle the stress. Steel composition inadequate. Manufacturing precision insufficient. The physics work against you. Redirect a supersonic projectile 90 degrees and something breaks, either the bullet or the barrel, usually both. Despite the fact that the bent barrel theory is in violation of accepted ideas on bullet delivery, it is believed to be worthy of extensive research and development. End quote. He suggests testing with the .45 caliber bullet, 230 grains, shorter length, large diameter, short bearing surface. Maybe different calibers work better. The Americans pursue this briefly. Experiments continue into early Cold War. Results remain classified, eventually abandoned. Precision-guided munitions make the whole concept obsolete. Why curve bullets when you can use missiles? Secret projects to reverse the tide. Most fail. V-2 rockets kill thousands but change nothing strategically. Me-262 jets arrive too late in insufficient numbers. Maus super heavy tank. 2 prototypes built. Never sees combat. Too slow, too heavy. Mechanical nightmare. Each Wunderwaffe diverts resources, engineers, materials, factory capacity, all wasted on weapons that do not alter the war's outcome. Clever engineering, impressive in concept, worthless in practice. The resources spent developing it could build more conventional weapons, more STG-44s without curved barrels, more Panzerfausts, more ammunition, practical tools that work. Instead, Rheinmetall Borsig engineers spend months perfecting a device that wears out in 300 rounds. Zeiss manufactures 1,500 specialized sights for 500 tank guns. That is 3 sights per gun. Wasteful. Steel goes into barrels that last 1 afternoon of combat. Man-hours into a dead-end technology. Never mind the fragmentation problem. The concept itself is the point. Show the world Germany still innovates, still leads, still possesses wonder weapons. Reality matters less than perception. Speer tries to redirect resources to proven systems. Tank production, fighter planes, anti-aircraft guns. Tools that work. Hitler overrules him, wants the spectacular, the unprecedented, the impossible. Krummlauf benefits from this environment. A bent barrel. Nobody else has one. That alone justifies production. The inaccuracy, the rapid wear. They return to standard barrels. A few keep the Krummlauf as a curiosity. Most discard them. Weight matters in infantry combat. Every kilogram counts. Carrying a 14-inch curved barrel attachment that breaks in one firefight makes no sense. Better to carry more ammunition, more grenades, items that actually help survival. Fire from inside the vehicle, protected by armor, but the 90-degree bend creates the worst stress. Barrel life drops below 200 rounds, accuracy terrible beyond 30 meters. Infantry assaulting a tank usually come closer than 30 meters anyway. Regular hull machine guns work better, wider field of fire, reliable. The Panzer 470A receives some Krummlauf mounts, exact numbers unknown. Post-war inspections find most unused. Crews prefer remote-controlled MG-34s. Curved barrels are even scarcer. Most assault platoons never see them. Those that do receive 1 or 2 per squad. For testing. Field reports are negative. Not worth the wait. Not worth the reduced effectiveness. Recommendations. Stop production. Focus on standard weapons. New equipment stops reaching frontline units. The last Krummlaufs roll off Rheinmetall Borsig production lines in January or February 1945. Maybe 500 total infantry versions produced. Maybe more. Records are destroyed. Factory bombed. Personnel scattered. Exact figures lost to history. What remains are the captured examples. Americans find several dozen. Soviets capture a similar number. Most end up in technical intelligence warehouses. Aberdeen Proving Ground, Wright Field. Sharovo Proving Ground. Engineers dissect them, test them, write reports, file them away. The concept remains dormant for decades. Modern militaries develop different solutions. Corner shot systems appear in the 1990s. Israeli design, camera and video link, pistol mounted on a hinged frame. Aim around corners using a screen. No curved barrel needed. Cameras solve the visibility problem. Bullet travels straight. Much more effective. Other nations develop similar systems. Some mount rifles, some use grenade launchers. All avoid bending the barrel. Physics wins. The few intact specimens become valuable, not for use, for history. Evidence of what Germany attempted, how desperate the situation became, how far engineers went chasing impossible solutions. All true, but the execution requires materials that do not exist in 1943. Steel alloys strong enough, manufacturing precision high enough, testing thorough enough. Germany lacks all 3. Resources are stretched. Quality control suffers. Engineers work under impossible deadlines. Rush development, skip validation. Production begins before problems are solved. Result? A weapon that works in demonstrations, fails in combat. The second lesson. Resource allocation matters. Every hour spent on Krummlauf development is an hour not spent improving STG-44 production. Every kilogram of steel bent into curved barrels is steel not used for ammunition. Every factory worker assembling Periscope Sights is a worker not producing hand grenades. In total war, this matters. Germany cannot afford waste. Yet the Wunderwaffe program wastes enormously. Pursuit of revolutionary weapons over incremental improvements. This is strategic failure, not technical failure. The engineers solve the problems they are given. Build weapons that curve bullets, they succeed. But solving the wrong problem is worse than solving no problem. Rational response: maximize production of effective weapons, focus on proven designs, improve logistics, train more crews. Instead, Germany pursues wonders, curved barrels, rocket planes, superguns. Each project promises to change everything. None deliver. This is not unique to Germany. All nations in crisis face the temptation. Believe the next invention will reverse fortune. Sometimes this works. Usually it fails. The Krummlauf fails. Technical specifications for reference: Krummlauf I infantry version, length 14 inches, total weight 2 kilograms with sight, barrel diameter 8 millimeters, bend angle 30 degrees, rifling twist 1 in 9.4 inches, vent holes 2 rows of 5, sight magnification 1.5 times, field of vision 12 degrees, expected barrel life 6,000 rounds per inventor, actual barrel life 300 rounds per testing, grouping 35 by 35 centimeters at 100 meters, effective range close quarters only, Versat's P tank version, barrel bend 90 degrees, total assembly weight 23.5 kilograms, mount hemispherical ball. Diameter unknown, sight magnification 1.25 times, field of vision 12 degrees, expected barrel life similar to I version, actual life under 200 rounds, maximum range for single shots 600 meters claimed, effective range sustained fire 30 meters tested, production 500 units confirmed, additional sights 1,500 units, case length 33 millimeters, overall length 48 millimeters, bullet weight 8 grams standard, muzzle velocity approximately 685 meters per second from STG 44, 700 meters per second from longer barrels, effective range 400 meters from straight barrel, under 100 meters from 30-degree Krummlauf, energy at muzzle approximately 1,900 joules, energy after curve significantly less, fragmentation reduces terminal effectiveness, multiple small pieces instead of one projectile, penetration ability nearly 0, useful only against unprotected personnel at very close range, one turn in 9.4 inches. After rifling completed, the barrel is cold bent, special fixture holds the tube, hydraulic press applies force gradually, radius of curve calculated to minimize stress, too sharp in steel cracks, too gentle and the bend takes too much length. 30-degree version curves over 5.5 inches. 90-degree version uses tighter radius, higher stress, more prone to failure. After bending, the barrel is proof tested, 5 rounds at full charge, inspected for cracks, many fail at this stage, rejected, reworked or scrapped. Surviving barrels receive vent holes, drilled precisely, 2 rows of 5, 10 total. Each hole weakens the barrel slightly, but without them, gas pressure causes faster failure. Trade-off accepted. Final step: mount assembly welding, threads for attachment, sight brackets, deflector shield. Each barrel hand-fitted, no interchangeability, very German, very time-consuming, very expensive. Distribution prioritizes assault platoons, elite units, those already equipped with STG-44s. 1944, fewer than 70 divisions have assault platoons. Most divisions still use Kar 98K bolt rifles and MP-40 submachine guns. The Krummlauf reaches almost nobody. Those who receive them file negative reports. Wasteful, ineffective, requests for standard equipment instead. But by late 1944, German logistics are collapsing. Requests mean nothing. Soldiers use whatever arrives. If that includes curved barrels, they try them once, then discard. Battlefield is littered with experimental German equipment, most of it abandoned after first use. Voigtländer designed earlier versions for 98K rifles with 30-degree bends. The STG-44 sight is more sophisticated. Prism mirrors, 1.5 times magnification for infantry version, 1.25 times for tank version. Field of vision, 12 degrees. Narrow, but adequate for close range. The mirrors are quality glass. German optical industry excellence remains high even late in war. Sight housing is stamped steel. Triangular deflector shield above the vent holes. Prevents gas from fouling the mirrors. Without this shield, the sight becomes useless after a few shots. Hot propellant gas condenses on cold glass. Coating appears immediately. Vision obscured. The shield redirects gas sideways. Keeps optics clear. Simple solution. Effective. Weight of sight assembly approximately ½ kilogram. Brackets bolt directly to barrel. Front sight post at muzzle. Rear aperture behind mirror. Aiming requires practice. Looking through periscope while maintaining cheek weld on rifle stock. Unnatural position. Soldiers complain. Difficult to use under stress. In combat, nobody has time to adjust. Point and shoot. Accuracy suffers. Bullet wobbles. Some tumble completely. Ballistic efficiency collapses. At 30 meters, this barely matters. At 100 meters, it matters enormously. Target grouping spread to over 1 meter. Beyond 100 meters, hitting anything is luck. The shotgun effect of fragmentation helps slightly. Multiple small pieces cover wider area, but kinetic energy divides among fragments. Each piece carries fraction of original energy. Penetration ability near zero. Thick winter coat stops fragments. Light cover provides complete protection. Even wooden doors block most fragments. Only against exposed flesh in very close quarters does the Krummlauf have any effect. This is why Soviet testing stops at 50 meters. Beyond that, useless. With the short length, large diameter, and short bearing of the 230 grain US caliber .45 bullet, various degrees of bent barrels might prove to be successful and with reasonable control. End quote. The .45 ACP round, pistol cartridge, fat, slow, heavy. Short bearing surface means less contact with rifling, less spin, maybe less disruption in curve. Theory makes sense. Testing probably occurs. Results never published. By late 1940s, the concept dies quietly. Guided weapons become the future. Anti-tank missiles, wire-guided, later laser-guided. Shoot around corners by guiding the projectile. Much better solution. Krummlauf research ends, files archived, forgotten for decades. Camera at front, screen at rear, shooter sees target, aims remotely, fires. Bullet travels straight, no curved barrel needed. Some versions use rifles, some use grenade launchers. All share same principle. Indirect fire around corners. Protect the shooter. Used in urban combat. Counterterrorism, hostage rescue, effective, reliable. Proves the tactical need exists. Germans identified the problem correctly in 1943. Their solution failed because technology was not ready. 70 years later, technology catches up. Modern corner shot works. Krummlauf did not. But the lineage is clear. Same problem. Better solution, progress. Direct mechanical solution to tactical problem. Bend the barrel, curve the bullet. Elegant in concept. Impossible in execution, at least with 1943 technology. Modern materials might work. Advanced steel alloys, ceramic-lined barrels, computer-controlled bending. Nobody pursues this. Why bend the barrel when cameras and screens solve the same problem better? The technology has moved on. The Krummlauf remains frozen in time. A fascinating failure. A testament to German engineering ambition, and a reminder that clever ideas need practical execution. Production ceased, company split between occupation zones, Western facilities become Rheinmetall AG. Continues business, eventually returns to defense production, still exists today. Major weapons manufacturer, tanks, artillery, ammunition, the curved barrel, a forgotten chapter. Company history mentions it briefly, if at all. Albert Speer, Minister of Armaments, tried at Nuremberg, 20 years imprisonment, released 1966. Dies 1981. His memoirs mention the Krummlauf briefly, evidence of Hitler's obsession with wonder weapons. Speer distances himself from such projects, claims he pushed for conventional production increases. History judges this claim skeptically. Influence on AK-47 design is debated. Kalashnikov denies direct copying. Evidence suggests otherwise. Similar gas operation, similar layout. AK-47 uses different mechanism, but general concept is identical. Intermediate cartridge, selective fire, stamped steel construction. The STG-44 proves the concept works. Every modern assault rifle descends from this lineage. M16, Galil, FN FAL, even British SA-80. All trace ancestry to German innovation. Sturmgewehr means assault rifle. The term enters military vocabulary, becomes standard classification. Hitler wanted propaganda name, got lasting technical definition instead. For 60 years, nobody tries again. Corner shot systems emerge eventually, but use completely different approach. No mechanical connection to Krummlauf, only shared tactical goal. The curved barrel attachment becomes historical oddity. Subject of occasional articles, YouTube videos, museum exhibits, collectors seek them, pay enormous sums, not as weapons, as artifacts, physical evidence of desperate times. When Germany threw everything at the wall, hoping something would stick, most did not. The Krummlauf is among the failures, interesting failure, well-documented failure, but failure nonetheless. Fewer than 50 complete original examples survive worldwide. Museums hold perhaps 20, private collectors another 30. Mix of infantry and tank versions, varying conditions. Some fired extensively, barrels worn out, others barely used. Near mint condition, captured before seeing combat. Each example valuable, not for function, for history. Prices at auction reach $20,000 for complete infantry version with sight. $50,000 or more for tank version with complete mounting system. Reproductions exist, modern manufacture, non-functional. Display pieces, even these command high prices, $1,000 or more. The demand shows lasting fascination. People want to own piece of unusual history, failed wonder weapon from Germany's last gasp. Life magazine photographer David Sherman documents examination of weapons found at Walther Factory, Zella Melis, Germany. Both Krummlauf types, infantry and tank versions. Officers study them carefully, take measurements, disassemble mechanisms, test fire repeatedly, collect data, write reports. The photographs survive. National Archives. Some published. Most remain in files. They show American officers examining bizarre German invention. Confusion on faces. Fascination. Disbelief. How did Germany think this would help? What were they thinking? The questions are obvious. Answers less so. Desperation explains much. Technical optimism explains more. Belief that engineering can solve any problem. Just need the right design, the right materials, the right manufacturing process. For Krummlauf, this was wrong. Some problems have no mechanical solution, not with available technology. Curved barrels are one. The physics work against you. No amount of engineering overcomes fundamental limitations. Logical. Outer edge sees higher stress, but thinner wall cannot compensate. Pressure too high. Second phase. Disassembly removes sight. Examine mirror quality. Zeiss glass is excellent. Even late war production maintains standards. Prism alignment perfect. Magnification accurate. Field of vision measured precisely. 12 degrees confirmed. Housing is crude. Stamped steel. Rough edges. Hasty manufacture. Third phase. Live fire testing. Captain Sharp conducts this personally. Multiple magazines. Different firing modes. Single shot. 3-round bursts. Full automatic. Temperature measurements. Barrel heat after 10 rounds. After 20. After 50. Wear patterns documented, bullet collection, every round recovered, examined under microscope, photographed, fragmentation patterns analyzed. Photographs, ballistic tables. Conclusions, clear, direct. The Krummlauf works in theory, fails in practice. Barrel life too short, accuracy too poor, reliability too low, but the concept has merit. Recommendation, continue research with different approaches, possibly different calibers, better materials, improved manufacturing. This reflects American optimism. We can make it work. Just needs more development. Germans tried for 2 years. Achieved marginal success. Americans think they can do better. They cannot. Problem is fundamental. Not solvable with World War II era technology. Not solvable with 1950s technology. Not solvable with mechanical means at all. Solution requires electronics, cameras, screens, remote operation. That technology does not exist yet. Will not exist for 50 years. Straight barrel. 685 meters per second. Through 30-degree curve, 450 meters per second measured, 34% velocity loss. Through 90-degree curve, under 300 meters per second. Energy follows velocity squared. 30-degree curve loses 57% energy. 90-degree curve loses 75% energy. Tests include barrier penetration, pine boards 1 inch thick. Straight barrel penetrates 6 boards. 30-degree barrel penetrates 2 boards. 90-degree barrel penetrates 0 boards. Fragments scatter. Steel plate testing similar. Straight barrel dents 3mm plate. 30-degree barrel leaves scratches. 90-degree barrel bounces off. Krummlauf useless against any protection. 10-round group at 100 meters, 20 centimeters diameter, with 30-degree Krummlauf, 80 centimeters, 4 times larger, 90-degree version. Group exceeds 2 meters, essentially random. The Periscope sight helps minimally, lets you see target, cannot help you hit it. First 5 rounds fire normally. 6th round causes barrel bulge. Slight, barely visible. 10th round, bulge worsens. 15th round, crack appears. Barrel failure imminent, with vents, pattern changes. 50 rounds fire before problems begin. 100 rounds, visible wear. 200 rounds, severe erosion. 300 rounds, failure. The vents extend life, do not prevent ultimate failure. They reduce peak pressure, allow gas escape, cool the curve section slightly. Trade-off is velocity loss, more gas escapes, less propels bullet. But without vents, the barrel explodes. With vents, it merely wears out. Better, still inadequate. This pattern repeats across German armaments. 1943 production, excellent. 1944 acceptable. 1945 terrible. Labor shortages, material shortages, bombing disruption, quality control collapses. The Krummlaufs reflect this. Early examples might last 400 rounds. Late examples fail at 200, sometimes less. American testers note serial numbers, cross-reference production dates. Correlation clear. Quality declines month by month. Final production batches barely functional. Test fired once, warehoused, never issued. War ends before distribution. Enemy infantry can approach in 6 minutes. Plant charges, escape. The whole point of Krummlauf is rapid defense. 6-minute setup negates advantage. Germans claim quicker installation possible with practice. Soviets disagree. Test multiple times. Multiple crew members. Fastest time achieved, 4 minutes. Still too slow. Americans reach same conclusion. Tank defense requires immediate response. Cannot wait while crew assembles weapon. Better solution. Pre-mounted remote guns, always ready, no setup required. This explains why Krummlauf sees minimal use, even when available. Crews reject it. Too complicated, too slow, too unreliable. Germans apparently assumed barrels would last longer. 6,000 rounds per inventor claims. Reality shows 95% failure before that. No contingency plan exists. Units receiving Krummlaufs have no spares. Use them until they break, then discard. Cannot repair in field. This alone dooms the weapon. 300 rounds per barrel. No replacements available. Weapon becomes disposable. Use once, throw away. Ridiculous logistics. Cost analysis reveals waste. One Krummlauf I infantry version. Estimated 50 Reichsmarks. Compared to standard STG-44, 150 Reichsmarks. Krummlauf adds 33% cost for 95% reduction in effectiveness. 50 Reichsmarks buys 15 hand grenades, or 80 Panzerfaust warheads. All more useful. The Versat's P-Tank version, worse. 350 Reichsmarks total, including Zeiss sight. That buys 2 MP-40 submachine guns, or 1 MG-42 machine gun. 500 tank versions at 350 Reichsmarks each. 175,000 Reichsmarks total. Pure waste. Germany cannot afford this, yet does it anyway. Desperation economics. Still would not change the war. By late 1944, Germany is finished. Soviet armies drive from east, American and British from west. German industry cannot sustain current production, much less add complex new weapons. The STG-44 itself reaches only fraction of units. Ammunition shortages limit effectiveness. Adding curved barrels helps nothing, makes situation worse, diverts resources, complicates logistics, reduces effectiveness of parent weapon, strategic impact 0, tactical impact negligible, historical impact, a curiosity, a footnote, evidence of a military in collapse, grasping at technical miracles, finding none. Test fired post-war, probably by Americans or Soviets, then preserved, returned to Germany decades later, now displayed as warning. This is what happens when military procurement goes wrong, when leadership demands miracles, when engineers build weapons without testing, when production begins before development completes. The Krummlauf embodies all these failures, sits in a glass case, silent testimony. Visitors photograph it, marvel at the concept, shake their heads at the impracticality, move on to next exhibit, usually something that actually worked. A normal STG-44, a Panzerfaust, a Tiger tank, weapons that made a difference. The Krummlauf made none.